Hi, my name is Lily Teal, and today I will be doing a tutorial on how to solve an evaporation pan type problem. Here is the problem that we are given. You will notice that I have bolded a few items within the problem. These bolded terms are given information that we will need to solve the problem. In this video, I will be solving each part of the problem separately. Here is a picture of what an evaporation pan setup may look like in the field. And now we will dive into the problem. Here is part A. It is asking us to solve the surface area of the pan. First, I looked up the surface area of a pan, or a cylinder, which is technically 2 pi r times the height plus 2 pi r squared. You will notice that I did not put 2 pi r squared in my equation. This is because our cylinder does not have a top, and therefore there is only one circle at the bottom of the cylinder. On the right side, you will notice that I have variables and their corresponding numbers. The radius r was calculated by dividing the diameter in half, which was a given item. Now, we will plug the known numbers into the equation and calculate for surface area. The answer that we come to is 3,264 inches squared. And as you can see, it is bolded. Here is part B. We are asked to calculate the volume of the pan. I looked up the volume of a cylinder, which is pi r squared times h. Like part A, we have known variables on the right side. These numbers were then plugged into the volume equation in order to solve for the volume. The answer is 17,720 inches cubed. Now we will move on to part C. Here, we are asked to calculate the depth of the water with a known volume. You can recall that the equation to find volume includes the height. Using this formula with a known volume, we can solve for h, or the depth of the water. Again, we have known variables on the right side. These known variables were then plugged into the equation and we solved for h. Now, the answer we got is 0.00649 inches. Now we will move on to part D. For this part of the question, we are asked to calculate the evaporation rate when we know the volume of water in the pan. First, we will use this volume of the cylinder formula to calculate the height of the water in the pan after evaporation. We set this volume equal to 10.2, which is given in the problem. Then we fill in the rest of the information with known variables. We know we're looking for h because that's the depth of the water. And we calculate h as 0.00576 inches. After solving for the depth of the water, we can use it to calculate EPAN. We calculate EPAN by taking the depth of the water at the beginning of this experiment and subtract the depth of the water after evaporation. This difference equals EPAN. We know that the pan coefficient, Kpan, is 0.75 because we learned it in lecture. Now, we'll use the formula for evapotranspiration to calculate the evaporation rate out of the pan. We can plug the variables into the equation and we come out with an answer of 7.73 times 10 to the negative 4 inches per day. Now here is part E. The question is asking us to calculate the depth of the water in the pan after 3 hours of precipitation at a rate of 0.5 inches per hour. We know that the depth of the water after evaporation, and now there is an input due to precipitation. We can calculate how much water was rained into the pan by multiplying the hours of precipitation by the rate, which is 0.5. We get an answer of 1.5 inches of water into the pan. Now, we can add this amount to the known height of the water after evaporation, and we get the answer here of the depth increased to 1.51 inches. I hope that you found this video helpful. Thank you for watching.